In this DGS tech tip, we're going to take a look at type resolvers in the framework, and also a way to just completely omit type resolvers. So a type resolver is required when you're working with either interfaces or unions. So in this example app here, we have a type of video, which is an interface, and we have two different implementations of video, movie and show. So looking at our data fetcher, we have a collection here that returns video, which is the interface, and the collection of videos includes both a movie and a show, and the data fetcher itself just returns all of them. So these types are code-generated, and because they're code-generated, we are kind of assured that the name of the Java class is exactly the same as the name in the schema. So in previous versions of the framework, what we would have to do to make this work is provide a so-called DGS type resolver. And what this does is basically for a given interface type, in this case video, you take a Java instance of that type and you figure out with an instance of if the interface type is either a movie and you have to return the string name that represents the type in the GraphQL schema, or in this case it can be a show. And if we have done this correctly and we start up the application, we can do a query that uses these interface fields together with the specific fields on the implementing types. And if you have a breakpoint in our video type resolver here, you can see that the instance that is passed in is in this case indeed a movie, which means the type resolver will just return movie as a type. And this is just kind of boilerplate code that the underlying GraphQL Java library requires, because it really doesn't have a good way of knowing that our movie Java type represents the movie GraphQL type. But especially when using CodeGen, it is a little bit silly because, well, these types are obviously connected, and CodeGen guarantees basically that these names will always be the same. So what we did in a more recent version of the framework is provide a default type resolver. And the default type resolver basically just assumes that your Java types are named exactly the same way as your GraphQL types. And with this new functionality, we can basically just throw away this whole class, and we can try to restart the app and verify that it still works. So we refresh our browser and it should be reloaded. And as you can see, you can still execute the same query, but we don't have this boilerplate code anymore. So there are still cases where you would still need a type resolver. If for whatever reason our Java types are called differently than the GraphQL types, we would still need a type resolver. And I'm going to emulate this by renaming the show class to series. And if we would restart the application right now and try to run our query, we will see that we run into an error. So we get a null result back. And if we are now looking in our application logs here, scroll up to the error. The framework tells us that the default type resolver could not find a suitable Java type for GraphQL type series. And that's correct because there is no GraphQL type called series. So in this case, I would have to go back to my type resolver. So let's restore this from history. So that's our type resolver again. We now see here that this old code doesn't compile anymore because we renamed this class. So let's rename it to series. But of course, the string name is still show here because the string name represents our GraphQL type, while this series represents our Java type. So that's an important difference here. And if you now restart the application once more, we'll see that this is all working correctly again. And because now we reconnected basically series to the show GraphQL type. This is somewhat rare to do. It is in most cases better to just name your Java types the same as your GraphQL types, and CodeGen does this for you automatically. But if, for example, you have existing Java types, before you start working on GraphQL and your schema design kind of prefers calling a type in a different way, then this could still be necessary, and you can do that with a custom type resolver. You can also combine custom type resolvers with default type resolvers. So if most of your types are named the same in GraphQL and in Java, but then one of your types needs special configuration, you can totally do that because you write a type resolver for a specific interface type here.